Here are a few devices created by the Telerobotic and Biorobotic Systems Lab at the University of Alberta, through the support of TELUS Ride for Dad Edmonton and the Prostate Cancer Fight Foundation. Additional funding was provided by Canadian Foundation for Innovation, Canadian Institutes of Health Research, Natural Sciences and Engineering Research Council of Canada, and Alberta Innovates Health Solutions. This is a wristband designed for a clinician to wear during prostate brachytherapy, a procedure where needles containing radioactive seeds are inserted into the prostate. This device consists of a series of 8 motors that vibrate in specific patterns to inform a surgeon about the optimal needle insertion path during the therapy. Here, a research assistant will insert a brachytherapy needle into a tissue phantom following the insertion instructions from the wristband. The wristband provides instruction on up-down and left-right movement of the needle base, as well as instruction on insertion speed. During insertion, forces on the beveled needle tip cause the needle to deflect away from a desired target location. One action that can be taken is to rotate the needle base. Rotation forces the needle to deflect in another direction and is the primary method through which a clinician can steer the needle. This handheld device steers the needle for the clinician during insertion to increase seed placement accuracy and reduce tissue trauma. With control of the needle deflection achieved, the seed can now be deposited into the tissue and the needle retracted. In current clinical practice, the needle is observed through ultrasound images, and these can be projected onto an augmented reality heads-up display. This heads-up display provides real-time information about the inserted needle position, needle deflection estimates, and the desired needle path. The display tracks the user's head so that a full 3D picture of needle insertion can be observed. The ultrasound probe is automatically moved during insertion to track the needle tip and provide real-time needle deflection information to the surgeon. The surgeon is presented with a predicted path of the unsteered needle, as well as an optimal path with needle rotation. Here, the surgeon chose not to rotate the needle and it continues down the predicted path. Thank you again to TELUS Ride for Dad Edmonton and the Prostate Cancer Fight Foundation, Canadian Foundation for Innovation, Canadian Institutes of Health Research, Natural Sciences and Engineering Research Council of Canada, and Alberta Innovates Health Solutions for their part in funding this research.